Replication, synchronous versus asynchronous. Which one powers modern systems? Have you ever wondered how companies like Amazon or Google ensure that your data is always available, even during high traffic or system failures? The answer lies in one critical concept: replication. In today's video, we'll break down the two most important types of replication: synchronous and asynchronous. We'll explore how they work, their pros and cons, and when to use each. By the end, you'll know exactly how to use replication to build systems that are not only resilient, but also blazing fast. Let's dive in. Replication is the process of copying data from one server or database to another to ensure redundancy, availability, and fault tolerance. In other words, it's like having a backup plan that's always on. Now, replication comes in two flavors: synchronous replication, real-time, reliable, but slower; asynchronous replication, fast and flexible, but with potential lag. Let's start with synchronous replication. In synchronous replication, data is copied to the secondary server immediately after a write operation. This ensures data consistency. Both servers always have the same data, but here's the trade-off. It can slow down write operations because the primary server has to wait for the secondary server to confirm the replication. Synchronous replication is like a perfect dance. Every step is in sync, but it takes time to master. Now, let's talk about asynchronous replication. Here, the primary server doesn't wait for the secondary server to confirm data writes. This makes it faster and more suitable for systems with high traffic or where low latency is critical. However, there's a catch. There's a risk of data loss if the primary server crashes before the replication is complete. So, how do these two approaches stack up? Synchronous replication prioritizes consistency over speed. Use it for financial transactions, billing systems, or critical data that must always be in sync. Asynchronous replication optimize for speed and scalability. Ideal for content delivery, logging, or systems where occasional data lag is acceptable. Synchronous keeps your data safe. Asynchronous keeps your users happy. The choice? It's all about your priorities. Let's look at how tech giants use these strategies. Banks rely on synchronous replication to ensure financial transactions are accurate and consistent across systems. Netflix uses asynchronous replication to handle massive traffic, ensuring fast content delivery without bottlenecks. E-commerce platforms often mix both approaches: synchronous for payment data and asynchronous for product catalog updates. Of course, replication isn't without its challenges. Network latency affects synchronous replication speeds. Data inconsistency is a risk in asynchronous replication. Storage overhead, more replicas mean higher costs. Here's how to handle these challenges. Use geo-distributed replicas to reduce latency. Implement write-ahead logs, WALs, to minimize data loss in asynchronous systems. And monitor replication lag and set thresholds to ensure performance stability. Replication isn't just about copying data, it's about doing it smartly to balance performance and reliability. To recap: 1. Synchronous replication offers consistency, but at the cost of speed. 2. Asynchronous replication is fast, but may risk temporary data inconsistencies. 3. The best systems often combine both for different use cases. In our next video, we'll dive into distributed databases, CAP theorem, and consistency models, a must-know topic for system designers. If you're ready to take your system design skills to the next level, hit subscribe, turn on notifications, and join me for the next episode. Because great systems aren't built, they're engineered with precision.